All right, hello everybody. This video is going to discuss the graphic sine and cosine functions and the basics of that and the amplitude. So I have the general function we're going to be discussing for this next week here, kind of changing all the parts of these functions. And at one point in time, we're going to have numbers in A, K, C, and H. But today on this video, we're just going to talk about amplitude and the basics of just the sine and cosine function. Now, you're probably looking at all these examples. I'm not necessarily going to graph all of these. I'm going to use the trick of our little equation drawing thing right here and kind of talk about what that looks like. But first, I want to just kind of talk about the basics here and actually do a problem similar to the ones you have on your practice problems, where I just have kind of a number line here and you guys are kind of breaking it down. All right, so I'm going to bring this up just a little bit. We did this in class the other day in which we broke down the different parts of the graph and we kind of looked at, okay, as it goes around, and we'll notice that there's key features here. At pi over 2, it is at 1. At pi, it goes to the midline, which in this case is the x-axis. At 3 pi over 2, it goes to -1, its lowest point, and then it goes back through the midline at 2 pi, which is 360 degrees. So you notice there's 4 key points here where it reaches its highest point, goes through the midline, lowest point, and goes back through the midline. And you'll notice that now it's just going to repeat the same thing going in this direction. And so when we have this is called the periodic length, the basic periodic length of a sine and cosine function. If k is not affected, which in all these cases k is not affected, so all the periodic length of these guys is going to be just 2 pi. Then the basic sine and cosine function just does one kind of rotation or one kind of full period, meaning like it's going to start repeating after 2 pi. So it does one segment, full segment in 2 pi radians. Okay, so it does this whole length there. Now cosine, same kind of thing here. If I put cosine in here, you're going to kind of get how that works. Cosine parentheses x, and you'll see that that one actually starts at the highest point, goes through the midline, lowest point through the midline, and then gets back up to its highest point. So the periodic length is still 2 pi, it just starts at the whatever the amplitude is, which in the cosine it's 1 because there's no number in front. All right, so I'm going to come back and reference this here in a little bit, but I just wanted to give you guys an example of problem kind of from your homework. So if you were to attack this, you notice that, let's do example 3 together here. So if I were to draw this, you'll notice that there's no effect to the periodic length, which is going to be in the next video. And so the periodic length is 2 pi, and I break that up into 4 segments. The reason why it's 4 segments is because this particular graph is going to reach its highest point, and it's going to go through the midline, its lowest point, and then back through the midline. We can find all these little pieces in between, but if we have a general kind of look at the way the graph is going to be, then we don't have to draw every single little point. It's just like similar to graphing a function on the coordinate plane. So if we have 2 pi, this is pi, 3 pi over 2, and pi over 2. Okay, so I broke up 2 pi into 4 equal parts. All right, and then the next video we're going to be talking about how to kind of find that. But for right now, it does one full cycle at 2 pi radians. All right, so for this one right here, you'll notice that this is example 2. You'll notice that the amplitude is 3, which means its domain goes from 3 to -3, means that's the function is going to exist between these 2 points. And so if I were to graph this, again, this is example 3, and this is similar to a problem you'll see on your kind of practice problems, is that you have these t-charts. And so what I'm going to do this, I know it's a sine function, so it starts at the midline. It goes up to its highest point at 3, goes through the midline, down to its lowest point, and back here. I'm going to try to draw this the best I can. You'll notice that it creates a nice little sine function here, similar to the one in the graphic I have right here, but I'll kind of show how it is affected. And then let's see example 4. All right, I'll kind of do this in red so we kind of see some kind of difference in sine and cosine. You'll notice that this one also has an amplitude of 3, so 1, 2, 3, 1, 2, 3. And again, there's no change in k. K is 1, so therefore the periodic length is 2 pi, and then it breaks down into 4 equal parts, 3 pi over 2, pi, and pi over 2. Okay, so its highest point is going to be, in this case, with the cosine function, it starts at the amplitude. So in this case, it starts at 3, goes down through the midline at the first quarter, lowest point, back through the midline, and back up. And so you'll notice that, whoa, that's bad. So you'll notice that as, if I want to do one full periodic length, I don't know if I'm going to get to that lowest point there, one full periodic length, it's going to end up where it started from, which is at the 3, and it went all the way back up. Okay. Now on these graphs, it's really hard to tell how this changes because I'm just kind of, the scale on the x-axis or y-axis is always the same. So let's pay attention to, let's talk about, I'm going to kind of show you guys what this looks like in sine. So if I put sine, or 3 sine parentheses x, you'll notice that it still has the highest point, but you know it's now going higher, and it goes lower than the basic sine function. So the amplitude affects how high it gets. Okay, so if I go through this rather quickly here, I'm going to kind of give you guys examples. I'm going to make reference now to the kind of graph I have here. So this is the sine one. Now let's say, for example, I put -2 sine in. Okay, so let's say instead of 3, it's -2, and try to imagine what it's going to look like. Let's see here. So if I have negative, in this case, example 5, which is -2, you'll notice that its first location, it starts at the midline and goes, it starts at the amplitude. So -2 is the first place it's going to go. It's going to go up and over. Okay, I'm going to make a quick reference here. I know this isn't one of the examples, but notice that if it's a negative sign, all it does is flip the function, which is very similar to the functions we've been dealing with the parents of graphs and things like that. All right, so we've done -2, so example 5. Now let's see what half looks like. Maybe if I put 0.5, and you guys can probably guess what that's going to look like. It's going to be a lot narrower. So it's going to be like, it reaches its lowest point, which is half right here, which in this case is -1/2, and then it goes up through the midline, then it reaches half, and then back to 2 pi. Notice that the periodic length has not changed whatsoever. It's still 2 pi. That's because k has not changed. This k should be in front of my x. All right, that'll be in the next video. So now to finish things up, let's talk about the cosine one. Very similar here in the patterns and how things affect the graph. So let's say, for example, I'm going to kind of follow along with my examples here. Let's say 3 cosine. So you'll notice that it starts at the amplitude, which is 3, and then goes back through the midline, lowest point, back through midline, highest point. Right? And you'll notice this is one periodic length of 2 pi. Now let's say if it does -2. -2. In this case, it's going to start at -2, go up through the midline, peak, back to the midline, and lowest point. Okay, so whatever the amplitude is, kind of where the cosine starts its pattern. Okay, now we have not yet talked about c and h, changing the value of those. That's going to kind of shift this thing a little bit, but we're kind of starting here with the basics. All right, so now let's talk about, let's throw out 5 cosine. So you guys can probably think about what this is going to look like. But you'll notice that, wow, it looks a lot bigger, but all it's doing is it's changing the domain. It goes all the way up to 5, goes all the way down to 5, but it still has the same periodic length of 2 pi. It means it's going to start repeating the same pattern here again over and over and over and over again. Okay? So this is the basics on amplitude and the basics with sine and cosine. So hopefully this was a helpful video. Please email me if you have any questions. Thank you and have a great day.